of the AI Summit Day 1. Very soon we are going to start the session. Welcome everyone. In the morning of the Day 1 of the AI Summit, we have witnessed 2 technical sessions based on governance AI, and the other one was based on healthcare AI. In the post-lunch session now, we are going to witness yet another technical session which is based on the robotics and automation. We have industry leaders amongst us, Mr. Kailash Desai and Mr. Samir Kerkar, who are the leaders of the field and who are known for the robotics and automation, the work they have been doing in this field. We feel privileged to have both of the stalwarts at the AI Summit. May I now request Professor Dr. Vilas Sapkar sir and Dr. Ashish Gadekar sir, Dr. Parminder Kaur ma'am, to kindly felicitate and welcome Mr. Kailash Desai and Mr. Samir Kerkar. Let's have a big round of applause. Yes. Thank you, sir. As we take the technical session ahead, which is based on robotic and automation, we are now going to witness the reverse pitch by Mr. Kailash Desai, Managing Director of Endress & Hauser. I now take upon the opportunity to introduce Mr. Kailash Desai to you all. A visionary leader with deep expertise in industrial automation, digital transformation, and process innovation, Mr. Desai has been instrumental in driving smart manufacturing and intelligent solutions across industries. Under his leadership, Endress Hauser India continues to integrate precision engineering and AI-driven solutions, empowering industries to become more efficient, sustainable, and future-ready. Today, we are proud to welcome Mr. Kailash Desai, Managing Director of Endress Hauser Group India, which is the global pioneer in measurement instrumentation, services, and solutions for industrial process engineering. Sir has a very vast experience in which he has taken very important decisions in making the organization effective. Having spent more than 2 decades with Endress Hauser, he has played a pivotal role in driving strategic expansion and operational excellence. Under his visionary leadership, the organization has achieved an impressive 18% compounded annual growth rate with exceptional momentum in critical sectors like water and wastewater. His strategic restructuring of the sales organization not only enhanced performance but also brought down attrition dramatically from 22% to an inspiring 4%, demonstrating his people-centric leadership approach. Before Endress Hauser India, he had held senior leadership positions at Emerson and also Pepperell and Fuchs, where he promoted cutting-edge factory and process automation solution across Western India. An accomplished engineer with a degree in instrumentation engineering and a postgraduate qualification in marketing management, Mr. Desai represents perfect synergy of technical depth and strategic foresight. Ladies and gentlemen, let us welcome Mr. Kailash Desai with a big round of applause. And I now invite Sir for his reverse pitch. Also, I would invite the solution team by students, including Hitesh Phule, Vansh Joshi, Sejal More, and Rohit Salunke, who will be presenting the solution pitch for the robotics and automation in the session 1. They are from MGM SOET. Yes.
Thank you.
Thank you, sir.
Hello. Hi.
This is your reverse speech.
Okay. You can use the slides.
Yeah, you can use
right? Sure. So good afternoon, everyone.
Good afternoon.
And welcome. Thanks for giving this opportunity to again all the MGM management. And it sounds, as you all know, this buzz of AI is moving across everywhere, and every person. I mean, whether how much in the depth they understood or not, but that's the spirit, which is moving across. So today, taking this opportunity, I would like to just take you quickly through already, thanks for my introduction. You all know this Anderson Hauser is a Swiss multinational company, and we are hardcore into this automation industry. So what the critical component, the things which is required as a prerequisite when it comes to automation, that's the sensors, and that's the core products for Anderson Hauser. More than 60 different principles, more than 800 different technologies, and more than 9,000 different variants of products. That's the products are manufactured in 19 different global production centers, with the headquarters being in Switzerland. That's a place called Basel. And well, of course, in India, I would like to just quickly, just to set the context and to give you some brief, as well as give the challenge to you, which we really look out from the industry perspective. I would like to take you through a couple of slides through which maybe also the audience as well as you all would get to know, and what exactly is the point which we can really add a value to the industry. Well, as I mentioned, this is our factory. This is a picture of our factory in Waluj. This is, you all know, in Sambhajinagar. And we are here since 2000, where we started one. It's a 50 acres campus, where we have almost all the 4 core technologies: level, pressure, analysis, temperature. All these products are getting manufactured over here. Well, the value addition for the products, it differs depending on what are the products getting manufactured. On an average, we have around 50% value addition. This means 50% of the items, components which are required in our products are manufactured here in India. Rest everything comes from Europe. And we have 450 employees across the country, 350 employees here in factory, and other 400 employees, these things. In just for the crowd to understand, today, including our exports, we are around 9,000 crores. That's the turnover what we do. And for Indian market, we do around 2,000 crores, for which I am responsible. And well, as I mentioned, from Sambhajinagar, we export our products to 50 different countries, finished and semi-finished goods. So that's the pride which our Indian employees, they really take for manufacturing the goods and send it to different parts of the globe. And that's one of the drive, which we keep on doing every year. We keep on increasing the countries. In Asia, we have 2 factories, one in China and second in Sambhajinagar. So from here, we cater to all the Southeast Asian countries till Australia, and also Africa, Japan. These are some countries where our full furnished product goes. Now, the topic which, before that, the topic which I selected, for which the industry basically really comes in, and automation, when we speak about robotic automation, that's the calibration. This is the topic which really comes in amongst, as compared to many other topics, which are there also equally important. So I just thought to just first explain you what are the big challenges in generic industry for the challenges. This is not only for one specific any industry. So all these 6 blocks, I'll just quickly touch base, like the generic challenges, what you see. That number 1, you see, the block speaks about the quality. Irrespective of which industry, which product, you all know, quality is a very known word, and it goes across everything. It's not only product, but if you want to apply, it goes across all the verticals both. And when it comes to industry revolutions, probably industry has really revolutions from 0, 1, 2, 3, 4, and now industry 5 is also coming. And what exactly this really brought into the industry is automation again. Initially it was horizontal, then it was vertical, then it was supply chain, and now industry 4 really brought in both horizontal and vertical. We have this automation which helps to the industry a lot. And we being from the technical side, we being the technical expert, it's always a challenge for us that how we really improve the productivity, how we bring in the products with less time, high productivity with less cost. But this quality becomes a very, very important factor, and it will ever remain that quality becoming a challenge, because unless you don't challenge, you won't really excel yourself, or your innovation don't come out. And the consistency in quality is always a challengeable part. No one can stand still that my products are always consistent in quality, And the important challenge, what I would say, is today, the sustainability in the desired quality for the products what we manufacture. Okay, so this is very important. I manufacture a product of a certain quality standards, and in our instrumentation language, what we call as repeatability. How repeatable I am for the accuracy what I say. So that's exactly will define the quality what is expected to be really coming out. So that's the first challenge. Okay, then we come on what are the factors which affect on the quality. Secondly, the pressure on competitiveness. As you all know, every day, if you Google out, if you go to YouTube, today if someone launches one product, tomorrow there are 10 other manufacturers who are coming in. So there's a tremendous pressure on competition, and which has to be, because that really excites us, that really keeps us motivated, and that's what is required. So this is again a very important thing, and again, very importantly, especially into the continents what we are, or in the country where we are, it's a cost. India, anyone who starts the product, first they think, how do I produce the good at the lowest cost? So the best quality in the lowest cost, that's the formula for India, always they try to really bring in. And that's what we all also do when we go for shopping. We want the best quality product at the cheapest rate. That's the mindset we carry. So this pressure on competitiveness is also there in industry every time. For every manufacturing anything, monopoly gets collapsed very fast. Lack of uniform solutions. This is one of the challenge. There are solutions. We discover solutions for a problem. But for the same problem, across the globe, there will be some other solutions. So uniformity in these solutions is always one of the challenge. And this keeps on discovering based on what exposure you have. Okay, we are fortunate today, we have very fantastic tools like ChatGPT, Micro Copilot, or whatever it is. This can help us to really touch base at one point. But still there is a lot to have a uniform solutions for the problems, similar problems across the globe. The next challenge, if I see, then it comes the utilization of technology. There's a lot. There's a lot today available. I'll show you in my next slide. In the ecosystem, there's a lot today available. But how much we really are utilizing the strength of technology what is available today with us. We have smart instruments, we have intelligent instruments, we have the best phones. We have every time we keep on getting so much of specification, which we are very curious. We want a phone which gives everything to us. But in actual usage, how much we really use. So that's one of the challenge which we see, optimum utilization of the available technologies in the industry. The next is, of course, a very known topics like safety, hazards, accidents. These are all the challenges which keeps on coming, depending on the processes or procedurals from the different level, different countries. If you go, the priorities. If you go to the western side, when they really bring in or they launch the product or the team which you want to bring the product, they start thinking from the safety point. How safe are the instruments? How safe are the products? Go to the German car. First they start manufacturing by saying is that how safe are this car, and then they start coming in. Where in India it is not safety, but it is more of price. So similarly, across the continent, you will have different priorities for really bringing in the products. So that's also one of the challenges for the products, same products getting manufactured across the globe from the different perspective what really bring in. Then the informal and fragmented pattern of recognition. See, there are some patterns, and obviously we all live with some patterns, And what are those patterns? Certain things repeatedly which comes, in industry, in processes, or in our behavior, or in culture, or whatever it may be. So these are the patterns which defines a certain action. And then which we name it, and then we qualify it. Like similar action, if it comes second time, so we try to connect with that pattern. If someone behaves with this pattern, even in the medical field, how the doctors, the diagnosis, they try to capture the patterns. If they see someone comes with a certain things, they know what is the pattern, and it comes. But this is again informal, and it's quite fragmented today, even in our industry. There are patterns, but then again, if I know this pattern for my machine, but it only I know an informal way, I really keep it. There is no really a formal way. There are still lot many things which are coming. So these are some general challenges which I see, like irrespective of the industry, whatever it is, manufacturing from a plastic mineral water bottle or till the time who manufacture the rocket. Everyone should have this kind of a problems which I have picked in. Okay. Now, this was a very good statement, I thought, just to set and give it to the crowd. This was actually a statement given by President of our Supervisory Board, Mr. Matthias Altundorf, who is also a good friend of mine. Once when we were making a strategy 2030, I was one of the core members for 2030, our strategy is ready now. So we know like which products we are going to bring in, which countries, what going to come, how to handle uncertainties after all the experiences, and today also some uncertainties are popping us. So at that time he brought this statement, which really sounded and hit to me. Like if you read this carefully, human beings are not good in predicting the future. You all agree with this. I mean, we are not, okay, we have Jyotishis, we have Babas, we go, whatever it is. We have our own perceptions, but we are not 100% accurate. So we are not good in predicting the future. But we are excellent in at retrospectively rationalizing it, what it means. For example, Wankhede Stadium, India out of 10 has always won 8 times, so 100% we are going to win the match. So we are very good. We know with England we played here, in this pitch, we always have been winning. So we are very good in basically rationalizing it based on the retrospective. So what has happened in the past, based on that we retrospective. So human beings are typically very good in this, very smart in this. So the message to the industries is like our goal is not to foresee the future because we may be wrong, but this is a very important statement. To build a system that can discover the future which helps us enough us to act on it. Now what it means to build the system, here comes I would say the AI into a very big picture. In this ecosystem which we need to really build up, which can help us to really discover the future based on which we can make our strategies. That will play a very important role. And that's the job of engineers, professionals, or all the big strategists who really make the strategies for their company or for the industry. Rather than going with your perspective, much more develop the systems. And this is what all the multinationals, all the top sustaining companies, they are really working on, to developing the systems. And then I thought AI plays a very, very important role when it comes to really bringing in this system. This will really give both the things, rather I would say also the accuracy of retrospecting. With the data which is available, the AI can really bring us to a much accurate level. And then obviously you can really build up the systems. So that was the statement which I thought to really set for this particular avenue so that you all also know what exactly it means. Now, as I said, calibration is the topic I have selected. So what are the prerequisites for AI, for an effective AI? So if you see all these points in terms of the calibration, okay, I'll explain you a little bit also on the what exactly, if you all know, but for the crowd, what exactly is the calibration. We being from sensor company, it's hardcore in our blood. Day in, day out, we really discuss on the calibration and bringing the standards. But today, the prerequisite in our calibration technology, which can support the AI, is the data. We have huge data available today on all the calibration technologies, all the instruments, more than 8 billion instruments today, they are there. We have all the list of these instruments today lying with us. And how they are, their calibration reports, this is available. All other points like calibration certificates, detection of the drifts, what has been in past for this instrument. We have each and every information captured in our intelligent instruments what we have. Optimized calibration intervals, how many times we have calibrated this instrument, why did we calibrated this instrument, what was the cost for this instrument, what made us to think, what were the different, all these things are available today, which are again prerequisite for the AI. And again, frequency, environmental conditions, physical conditions, the principles based on which the products which we manufacture, what are those principles, how this principle can get the instruments which we have, how they can really behave on the principles at different conditions. So all this data is available with us today, and this is what I would say the prerequisite for calibration is available with us. And this is the ecosystem, couple of products. These are the typical, very standard products for Anderson-Hauser. As I mentioned from the 60, this I just picked up. These 4 technologies, what you could see from the left, we have level, then we have flow meters. We have again the level both in liquid as well as gas. We have pressure transmitters, we have analyzers, and then also we have the mass flow measurement, inventory measurement control products. Now all these basically are sensors. And in this automation industry or in instrumentation industry, what we call the measurement is very important. Measurement and then control over the measurement. That's the simple definition of instrumentation and as well as automation. So you need very strong intelligent sensors available with you. And these are, we call a very intelligent sensor, means these are so powerful. The brain of all these sensors, they carry all the information which I explained you earlier. And which probably even now in industry, when we sell our products, with our gut feeling, we says industry today still use only 15% of the intelligence which is available in this instrument. We have all the good words, smart and the heartbeat technologies, the MemoSense technologies. These are all the technologies which are available, but still industry is far behind to optimum utilization of all the intelligence which is available embedded in these sensors. So this ecosystem is already existing, when it comes, and this is since from Anderson Hauser, but across all the companies and industries, you will have similar kind of products today available, where they have these intelligent sensors for ready available, which can give also support to the calibration details. But the technical gaps, as I mentioned, like if I select these three are the major technical gaps today what we see. The first, the manual locks. Still today we require people to take their helmets, wear their safety shoes, go to the site, check the sensors, get the conditions of the sensors, go with the tools, get the data with them, bring in, log it, keep it in a sense. And then they use it for your ISO certification, they use for internal audits, they use for statutory audits, whatever you want. So still these manual logs are there. Next is detection lags. Like current sensors, if failures, why do they fail? We really don't have, actually, we can predict based on the intelligence of the sensor, but the perspective is still not clear. Like, why do we predict? When do we predict? What are the intervals? There are no really some standard rules, although these are all defined based on the user, but regulation still keeps on evolving, like how we can really bring in these lags, which need to be detected on the real time. And the next is the data silos. Still there are a lot of data, but these are available in different silos. So these are still the big technical gaps what we see. Now coming to the calibration. As you all know probably, but what's exactly meant by the calibration? So this is a simple process in which, the instrument or the sensors, which is to be used for the purpose which is going to be there. So this instrument needs to be really compared with respect to some standards and international standards or the measures what you have. Identify the error, how this sensor really performs. Because let's say you manufacture this sensor, but when you manufacture it's basically a mechanical piece. So when you have to give a name to it, you need to take it to some reference standard, compare what's the error for the purpose which is being used, and then these errors are basically corrected by applying the factors. And these all are derived in this calibration process. Obviously, your standards need to be the best accurate thing first, and then the process by which you use this calibration. This really qualifies. And that's why you have the world-class best standards, ISO 17025, 9185, 4036, many different standards for different, purpose or the autonomy which you use. And then you start using these standards. The standards have some standard operating practices. You use these SOPs and you start calibrating. So once you believe, let me give you an example. You go to a petrol station. You fill in a petrol in your vehicle. You ask the guy to fill in 1 liter petrol. He fills in. You believe in the reading what you get and you pay. But do you know really whether you got a 0.9 liter or you got 1.1 liter? You don't know. But the nearest to reach 1 liter, that's basically the calibration again. If this instrument is calibrated to the best, the factors which are generated to measure that 1 liter, the quantity, the mass which gets converted into liters, that's basically define the quality of calibration. And that applies everywhere. Whatever you measure, even you're measuring tape or a scale or any measure which measures the liquid, everything goes with the calibrations. How accurate are your calibration? And this is what, it mentions. If you have the best calibration, best calibration standards, ultimately it is going to help you to really achieve the best quality. Okay? And now coming like the challenges in the calibration. So there are two things which we see that can really affect the calibration. One, the inherent instrument, what it is being used for. Second, the process condition, what is used for. I have a flow meter. Okay, this flow meter, which measures the flow, let's say for example, by using Coriolis principle, this measures the mass flow, the quantity which is flowing. Now, the Coriolis principle itself, it defines its metal piece the forces which are generated because of the object which is moving on the rotating body. This really brings in some forces, and this is applied in the industry to measure the liquid which is flowing through the flow meter. Now, based on this principle, you make the flow meters, you get it calibrated on the rigs, and then we sell it to the people. And these meters are used for 0.05% accuracy. All the petrol stations or the gas stations, the meter which are installed inside, these are expected to operate at that accuracy. Because you pay, all the transitions are based on that. Now the calibration can get affected because of two things. One, the physical properties of the instruments which are being used. Now the physical properties, the metal which I'm using, if I use a stainless steel, what is the modulus of elasticity? What are the temperature effects on that particular tube? If there is a change in the temperature, there will be a physical changes in this instrument. So that can affect the factor which are used to generate the calibration factor. Second, the industry process conditions. You are using for different liquids these flow meters. This liquid can erode or corrode this instrument, and that can drift the calibration. So these two are the major factors for whatever instrument you are using in any field, in medical field or in your day-to-day work or whatever it is, be a thermometer, be it any blood pressure testing machines, everything. Every measurement what you do with the calibration. With the number of cycles, this calibration can drifted. The biggest challenge today what we see is that everyone make their SOPs based on their experience. And then what happens, like for example, I know this particular instrument, if I use it for 6 months, for example, you purchase a motorbike, what does this agent tells you? Sir, you bring your first time for servicing, either after completing of 3 months or after going 100 kilometers. What does it mean? Have you ever thought about it? This is exactly what they think about. Like if it is being used or any of this aging effect can bring in the change for the average what it is to be used, or the components which are weared out in the first 100 kilometers, they need to reset again for that particular factor. And that is the reason. Now, why do they say 3 months? It is based on the past experience. And these are SOPs. What happens, the drift happened after 1 month only. No one knows. So for that balance 2 months, there's a big change in the quality, what it was expected. And that's the big challenge today which we see, and what we call is the real-time correction of the calibration factor. Rather than waiting for those period and taking these instruments for recalibration again the standard and giving it back. The losses which are incurred because of the real-time effect drifting, and this is an ongoing and continuous process which happens, and depending on the application, depending on the liquid, depending on the area, depending on the standards, all the SOPs are really defined. Now, if I want to just throw a ballpark figure, a single drift used for a couple of months, this can cost $1.2 million. This is just one of the pharmaceutical examples, but it's a big headache. It's a loss of revenue. It's a loss of quality. Just imagine if this goes into biomedical, this goes into pharma, how critical these are things. So here comes the expertise, here comes the industries, here comes the development guys, but all this data what we get from this is all based on our experience. Again, retrospectively we keep on really working and predicting like, okay, this is what it could be. And well, if you see, there are regulations, you all know, all standards, quality standards, regulation standards, especially into the pharma industries. These are some of the examples: API, EI, ISP, FDA, EMA, OIML. Now different industries, they capture these standards. What are these standards made for? Now these standards, they define the standard operating practices for calibration of this instrument. And where do they get from? All these experts, they get from this experience itself. Again, I repeat, this comes from the experience. This comes from what it comes from. But still, the challenge is, like, how can we really get this the real time? And that's what I would like to put it in front of you guys, that we need a system that detects a physical drift in real time before it violates the compliance of what we call it. Your solution must be plug and play, user-friendly, for the legacy hardware of the global titans who are being using, turning easy sensor to a self-validating node. Because this should be very well universally accepted, a generic solution, and which can really add a big value, can solve for this particular industry. And well, what are the benefits if we can achieve? On manual side, the integrity level, it can give to 65% confidence. But if we can really go through the AI augmentation standards, then it can go up to 99.9% precision. And one of the biggest thing which we can save, which can bring in consistency in the quality, which we can save the costs, we can improve the productivity, we can improve the efficiency of production. This can be achievable if we really, on the calibration front, if we can really bring in AI into our embedded system, what we can. How E&H can support in this ecosystem? As I said, we have a data. We have a huge data available with us. Domain expertise. We do have our IT team in Germany, which they sits. They are day in, day out. They keep on working on the data which is coming to us. Today also we are far ahead when it comes to AI, but into the proposals, into making the budgetary quotations, into really thinking from the customer history, which standards customer has been using across the continent and giving it. So all this domain expertise we have with us. Calibration, we have multiple peoples, all the top class world, be it PTB, NMI or Swiss Meta, all these standards we have our own colleagues working over there. So that expertise is available with us. And then of course we are ready to really think out on the pilot. If someone really brings this, we can really bring it to you all. I hope I had set the context and on the calibration front, what would be the challenges and how AI could really bring it to us. Thank you. So any questions, any things which you want to get it clarified, please feel free.
For now, there are no questions, but after presentation we can discuss on that.
Okay.
After our solution.
So all clear?
Yes, sir.
So when do I get my solution?
Yes.
Good.
Sir, first of all, thank you so much for giving us this opportunity to present our solution in front of you. We understood and also appreciate your problem statement. We have proposed our solution named as CalibraSense AI, which will solve the problem when calibration truly matters. It transforms sensor calibration from routine maintenance into intelligent system. Solving the solution stage of this prototype is maximum viable product, working AI prototype dashboard. So the million dollar problem we understood is that the problem is not really the calibration. The problem is knowing when calibration truly matters. And also we understood and identified the critical gaps in the current systems. As you mentioned, sir, in today's current system, the fixed time based, the calibrations are fixed time based. It is scheduled when to do the calibration and when not, according to the sensors. And single sensor monitoring currently. There are no multi-sensor correlation monitoring. Then no real-time fouling analysis. Reactive drift detection means the current systems wait for failure rather than predicting. When the failure comes, some systems, then they take the action and then they calibrate or improve the device. And last is the absence of risk prioritization. In this, current systems know that this is not calibrated, these sensors are not calibrated, but this is not prioritized, like which sensor need to be immediately calibrated according to their importance level. This needs to be prioritized. So this is the main busy slide, full solution brief. CalibraSense AI is an AI-driven risk-based calibration intelligence system which will continuously monitor sensor data, and it will detect drifts using time series learning and generates risk scores according to in which it uses various AI models like LSTM networks for finding the patterns and detecting them. The isolation forest is used for anomalies detection. And fast Fourier transform for if there is any fouling on the sensor, like the material covered on the surface, sensor surface. So it will create the signal degradation. And biasing risk modeling with the help of bias theorem, it will calculate the risk from 0 to 100. Instead of giving a value like yes or no, like no or yes if you have to calibrate or not, it will give a scale value, risk score. So according to it, we can analyze and do the calibration. In the left side, there is the architecture flow. These are the 6 main layers in our solution. First is the data acquisition, then drift detection, anomaly detection, correlation validation, then risk scoring will happen, and also it is explainable by the AI. And these are the technical architecture, like integration with your system, PLC and SCADA systems, edge computing devices will be attached to it, ERP compliance to control it and all. Our solution is not just monitoring software, it is a risk-based calibration nervous system which will calibrate the risk score according to this general formula. This general formula, it will calculate the risk score, and as soon as, and when the, another point in it is that when the fouling is detected, automated cleaning cycles will be triggered, and the cycles will be started, making the system not just predictive but self-healing. It will start the cleaning, and if there is any fouling problem, it will be removed. This is the prototype. I will show you once again. So this is our dashboard. This is a PCI module predictive calibration integrity. In this, there are live and pause control available. Also the speed controls for accelerating or slowing the drift simulation. And there is a weight scale. I will show you how this works. There are 5 summary cards which acts as the filters to these 5 critical points. So in monitor, like it is showing 6 instruments. So currently in the system there are 6 sensors we have integrated. So this is the sensor ID. This is the unit and sensor name along with its location, where it is planted or not. And this is the process the sensor governs. This is the status of the sensor, and when we analyze, so this is the in the analyze tab, it shows us the full detailed plan of the sensor, like overview tab, analysis tab, and action tab. In overview, you can see various parameters like this is pressure transmitter, so current value, drift rate, cycle count, and days since last calibration. It will track the record and update it likewise. In analysis, it will show AI assessment parameters like drift velocity, projected breach, environmental risk, and good practice impact assessment. And in action, these are the parameters for the calibration according to the sensor wise. So it will show the recommended action we have to took for if there is any drifting in the system. These are the recommended actions by it. And as we analyzed and done this, we can select as mark as recalibrated. So this sensor, which was pressure transmitter, it goes to the normal card. It was previously in the critical one. So now in the normal card, we can see pressure transmitter. So its status is now clean. Status is clean. It is not showing any risk score. Risk score is maintained. We can also again recalibrate it in the normal tab. So it will get removed from the critical one. So likewise, we can analyze and control all the different sensors in this. So this was our dashboard. From now, Sejal will continue.
Good afternoon, sir. Moving forward from here, we have the outperforming the status quo, the capabilities being risk assessment, and to which the Calibra Sense AI, the AI model that we've prepared, provides risk-based scoring engine. Like if there is risk assessment, we provide a score ranging from 0 to 100%, in which it will state at what point calibration is truly needed. The score ranges from 0 to 100, in which 0 to 40 is the watching level, like you should be watching the calibrations, and 40 to 70 will be alert levels, that it should be scheduled from now on. And if it is ranging from 70 to 100%, then it is in a critical level and it should be immediately calibrated. Otherwise, the batch production might be getting in loss. Now, the next we have is monitoring approach, which is multi-sensor correlation. We won't be checking just one sensor. It can happen that maybe, as this is the advisory module, so it can happen that the percentage might be in 40 to 70, but it could be also the possibilities could be that the liquids are, if we take the example of liquids, that the liquids might be contaminated. So it also checks the correlated sensors, and by that it can show us if the calibration is truly needed or it is just the sensors issue. And then drift detection, predictive time series modeling. We use the TSD, time series data, the data which was previously available with us, and with that data, we check if the calibration is needed or it is the sensors issue. And similarly, explainability and fouling response as self-healing cleaning cycles. So now we've solved the given issue of 50 lakhs, considering that industry has 100 batches per year, and out of those 100, 5 batches are drift failures. So per batch, 50 lakhs are lost, considered as loss. So if we take the, and if we multiply that 50 lakhs with the remaining 5 batches, it is 2.5 crore loss. So if we assume now that we are working with the Calibra Sense AI, so with that assumption, if we consider that the number of 5 failures drop down from 5 to 1, then the losses of only 50 lakhs rather than 2.5 crores, and the annual saving becomes 2 crores. It also gives the 30% reduction in unnecessary calibration events when they are scheduled, but they are not actually needed. So that could be reduced, and 50% downtime cut. Now, what we truly ask is not just the data from your industries, but we need something more than that. Our request for you is the historical sensor telemetry, live SCADA integration, test line access, and furthermore, most important, the quality engineer partnership. With this, we can fully and successfully integrate the Calibra Sense AI with your industrial work. Thank you, sir.
Thanks. Good, quite impressive. I would give my comments as like, okay, the context is very clear for you guys. And also I really appreciate the approach which you are trying to address. So from the last slide, I would just pick up 1 and 4 is done. You can go ahead, like, you know, for the historical sensor, telemetry or quality engineer partnership, we are always ready to welcome. On the 2nd and 3rd, this really needs to see the live cases where, you know, we need to do these pilots, and for which we need to be a bit careful which area, which domain, and this needs to be explored, you know. So this is how I think we can really welcome and start taking the transport you have got. But quite impressive, very good. I mean, I would say the thought process which you have put in, which really is addressing the couple of points which I have said. Now, well, the nitty-gritties, the core things, the intervals, the percentages, what you mentioned, or, you know, the topics what you also picked up with respect to where to really address the issues, the dashboards, these are all like, you know, on the case-to-case basis where we can really evolve, and which I think is really good, and how to integrate with the different technologies, different sensors and different applications that can define the core thing which we can connect. So I think fair enough. Good job. Well done.
Thank you so much, sir.
Thank you so much, sir, for the brilliant reverse pitch and also guiding the students on the solution pitch. We really thank you for your presence and for your expertise here at the AI Summit. May I now request you to kindly be here on the dais for the group photograph with the students. Congratulations to the students of MGM University, SOET. I'm sure this is going to be a day you remember throughout your life. Thank you, sir.
Now we move forward to introduce our next eminent leader. We are truly honored to welcome Mr. Samir Kelkar, the CEO and R&D head of Grindmaster Machines Private Limited, a globally respected name in precision metal finishing and advanced manufacturing technologies. An engineer by passion and an innovator by purpose, Mr. Kelkar has spent over 15 years transforming the landscape of specialized machinery in robotics and automation. He is the visionary architect behind the revolutionary RoboFinish range, a breakthrough that has redefined grinding and finishing technologies for ferrous and non-ferrous castings, setting new global benchmarks in quality, efficiency, and automation. Under his dynamic and forward-thinking leadership, Grindmaster Machines has expanded its footprints across China, Europe, and the United States, positioning India as a serious global force in high-precision engineering. His relentless pursuit of excellence has led to the development of more than 15 patents, innovations in advanced finishing and robotic technologies, significantly impacting the automotive and powertrain industry worldwide. With international R&D experience in Switzerland and a strong academic foundation in mechanical engineering, Mr. Samir Kelkar combines global exposure with Indian ingenuity. He is also the author of Garage to Global, an inspiring account of how determination, innovation, and belief can transform a small beginning into a globally recognized enterprise. Ladies and gentlemen, please welcome Mr. Samir Kelkar for our next track. I also invite the next team, solution team of Mubashir Inamdar, which has been represented from School of Engineering and Technology, to be please present on the dais.
I can speak into this, right? Okay, good. It's like very happy to be here back at MGM University and speak about how to deploy AI into finishing, a grinding and a finishing domain. The title of my speech is called Solving the $1 Million Challenge. And the reason why this figure $1 million is chosen is that almost every imported machine which does high precision work of a grinding is about $1 million. $1 million is today more than 9 crore rupees. With import duties, it is about 10 crore rupees. So you can consider that each of the grinding machines which the nation imports is 10 crore rupees. To give you a perspective, India's machine tool manufacturing is about 14,000 crores a year. We don't have to be too happy about it because India's import of the machine tools is about 16,000 crores a year. So we are importing about 55% of the machine tools that we need. Yeah. Most of these imports, out of that like 16,000 crores, most of the imports, I would say about 60 to 70% of it, it comes from European or like Japanese companies which are able to make the machine tools of a higher accuracy and which last a longer time compared to the machine tools that are built in India. Very large amount of them will be a grinding machines. Yeah. So the title that like I'm making the reverse pitch for is to solve the $1 million precision machines for a grinding. The context is to develop a technology which will have a local root, which will be like truly be designed and built in India. To give you a little bit of a background, we at a Grindmaster are mainly building micro finishing and super finishing machines which are used after the grinding process. So typically most high precision parts, you can take a crankshaft, a camshaft, a bearing, or EV like motor shafts, like rotor shafts. All of these components, they go through the machining process. Then they would go through the hardening process. After the hardening process, they would go through a grinding process. And subsequently, they go to the super finishing and the micro finishing process. Like we have gained an expertise in the technology of the finishing process. Due to the specialization in the finishing process, we are able to export 60% of our machines to the world, including like China, like Japan, like USA, like Germany. So while the country is importing 60% of its like machine tool needs, we as a company are exporting about 60% of our production, which is a drop in the ocean of like manufacturing. So as a company, we believe in a make in India and make for the world. So any technology which we develop or which we get into, our objective is always to make the technology of a quality and of a specialization with which we can export it like worldwide. Machine tool industry in general is a strategic industry. So it is the backbone for the manufacturing industry. To make anything of a value, you need to have the machines which can make it. You want to make a tank, you need to make an engine of a tank. You need to make the barrel of a tank. To make an aeroplane, you need to make the turbines. You need to make the landing gear. So to make high precision parts and to make whatever you want to make in a manufacturing, you need to have a very strong base of the machine tools. Like the second key strength that we have in a Grindmaster is to develop an ability with a local talent. We have most of our engineers are from the Marathwada region, to build the local talent to a world-class engineering setup, which can meet and exceed the global benchmarks and set a new benchmark on various technologies, its processes. So this is what, I mean, the process technological expertise that we have in the finishing and the high high level of engineering and a quality which our engineers like bring will enable us to have this culture of engineering excellence, which which enables us to do what we do. Like, so now coming specifically to the problem. What is it that like generates an accuracy in a grinding machine? So the tolerance is a stack up of a number of things, including the thermal like deformation in the machine, like the variation, run out in the spindles, the coolant temperature which heats up the part, like wheel wear, a grinding wheel which keeps like wearing like over a period of time. So it is a stack up of the tolerances. Now, if you look at the typical requirements for high precision like shafts or high precision like raceways of the bearings, the tolerances are of a tune of 1 micron to 2 microns. 1 micron is 0.001 millimeter. It is much like thinner than your hair. So what you're saying is that the combination of all those factors, whether it is the thermal like stability, whether it is the coolant, whether it is the run out of the spindle, the sum total of the stack up of those tolerances has to be still be like well under the 1 micron accuracy which you need on the part. Yeah, so this is a challenge. Yeah. Now the traditional way of solving this like challenge of the machine tool industry in general, whether it be the machine tools in India or the machine tools in Europe or Japan, a traditional way to solve this challenge has been to minimize each of the stack-ups. So your like machine ka structure is made out of a steel. It has a thermal like stability. It like deforms with a variation in the temperature. Like everybody knows, we in India have a big variation in temperature. It is like 20 degrees in the winter. It is like 45 degrees in the summer. So the way that the machine tool industry has been typically been solving this like challenge is to go for like materials that give a thermal like stability. So for example, as compared to steel, if you are constructing the base out of a concrete, it is more thermally like stable. Or in a worst, like, or in a more extreme situation, if you take a large block of a granite stone out of a mountain and you cut it to exactly the same size as your base and you use that as a machine base, it is more stable than even the poured concrete. Yeah, like so, like this is a traditional way, and that's why I'm saying that we are using a static solution to solve a dynamic problem. Yeah, like so our like solution, like whether it is in Europe or Japan or in India, is to use a static solution. You use a thermally like stable like material. Now, the Germans and the Japanese, when they have invented this kind of a solution, did not have access to AI. Yeah, like so they invented these like solutions in the 1980s, in the 90s, in the 2000s, and they did not have access to AI. Now we, like since we have access to AI, if we are developing these solutions, it gives us an opportunity to not to match, but to leapfrog. Yeah, because like one approach is कि like German आदमी ने ऐसा किया है तो हम भी वैसा करेंगे. Like Japanese ने ऐसा किया है तो हम वैसा करेंगे. But another approach is we now have access to more superior technology. So we should use that more superior technology and solve these problems in a different way, different, unique, and original way. What do we do by like solving this problem? We generate a higher machine like accuracy. We are able to make, specifically in the field of the grinding machines, if we solve this problem, like we will be able to produce like machines which will make us truly Atmanirbhar. Not only like Atmanirbhar, but we will be able to beat exports. We'll be able to beat European companies, will be able to beat the Japanese companies and be able to export our machines to these countries. Which is a key factor of being a Vishwaguru. I would not be able to call ourselves as a Vishwaguru if we are importing about 60% of the machinery which we need in the country. So it is essential that we develop it from a technological perspective in order to build the nation and to move the nation into the next decade. This is another example of the staticness of our systems. So with the static fixed CNC parameters, with a little bit of operator intervention, we are able to get a better accuracy. So out of these three, the first two have been extensively been used. But the third parameter, which is AI adaptive controls of the machine. So here we are talking of making a real difference to the accuracy of the components that the machine is going to produce by using AI. What is exactly the task? We have exactly the task is to do similar to how AI or machine learning has been used in the control systems to tune a servo motor or to tune a drive. Similar to that, we need something to tune the entire machine and to keep tuning it again and again. For that, a lot of data, including the vibration analysis and all that, is available. You can put all sorts of sensors on the machine, generate the data from it, and use the data to do a variety of things. There is a necessity to guarantee the quality. So you not only have to generate the quality, but also to guarantee the quality within the closed loop of the machine. Having a separate facility for inspection, a separate facility for doing a quality check is very soon going to become the past. We need to build a machine in which the part quality is also inspected in the machine itself and is guaranteed. 90 days is a tough pilot roadmap, but as a proof of concept, it is doable to show on what level AI can reach. Then of course I can understand that it will take a much bigger research activity and a project to actually to realize it in the field. I would like to explain this with a story which is pertaining to the research that I used to do as my master's thesis. So I did my master's thesis in a FANUC robotics sponsored lab in the University of California at Berkeley in 2006 and 2007. There were about 10 students, including me. Somebody was doing a PhD, 2-3 other students were doing a master's, and we were all working on the problems related to applying machine learning to optimize robot motions. We came out with a bunch of research papers and presentations. We made those presentations, we submitted everything to the headquarters in Japan, and we passed out wondering in 2007 if this research was of any kind of a use in industry or not. Because we had done our job, we had published the paper, we got our degree, and we were out of there. So I was very surprised, very happily surprised in 2015, when FANUC launched the Genkotsu version of the robot. And when I went through the material of the robot and I contacted the Fanuc team at that point of time, I realized that 70 to 80% of the content of that new version of the robot had been in the research lab 8 years ago. So research in equipment or research in manufacturing fields, it takes a certain amount of time to deploy. It takes a certain amount of time to robustify and see, because whatever you are doing here, whatever algorithms or whatever is being done is having a real impact on the ground. If it doesn't work, it will produce a lot of bad parts. So it must be tested very rigorously. It should go through a very strong validation for it to be put into the field. As a grinding and a finishing expert, we have a very rich data with a wide variety of applications. I have cited the precision finishing and grinding applications today, but similar technological concepts, they can be used across the robotics and the machine tool domains. We have a very strong research facility or a research setup at our facility. Almost 10% of our team is dedicated in research and development, doing a wide variety of things. We have already 3 patents in machine learning for the micro finishing and the super finishing as a process. Yeah, and we have the best people who know the finishing for a long, long time. So I'm happy to hear the solution that your team has developed, and if you can present that. I am also happy to take any of the Q&As, any doubts or issues that you might face. Thank you.
Thank you, sir, for giving us opportunity to pitch our solution. Before pitching, let us discuss the main actual problem the robotic grinding machine are facing in manufacturing industries. Grinding is one of the most important finishing process used in manufacturing industries for finishing and smoothness of surface. In manufacturing industries, robotic grinding machines are widely used for finishing because it provides speed, accuracy, and precision. However, the current robotic grinding machines depends on fixed value input from manually, from given by human. Means operator have to give a specific depth or in microns to cut the surface, and taking that as a instructions, robot cuts the surface. But in manufacturing industries, in real manufacturing industries, the surface are not plain or even. They have depth, patches, and uneven surfaces, which these robots cannot detect. And they cut the surface simply all over the surface, and which reduces the surface quality, finishing, and efficiency. The problems current robots are facing, grinding depth is pre-programmed, means they are not adaptive towards the surface. The surface changes, they doesn't change the programming or according to them. And surface unevenness remains the same even after grinding. Multiple grinding cycles are required, which increases the production time. Poor surface finish is still there, and efficiency reduced. And no real-time surface analysis in microns are shown. For in industries like where precision is one of the most important thing, like aerospace, automobile, and tool manufacturing, these small irregularities create a huge impact on quality. So the main problem of these robots are they doesn't have ability to analyze the surface and take decisions accordingly. So for that, our solution is Grind Mind AI. Mayank will continue from this.
So as he explained the problem, our solution is our AI-powered robotic grinding machine, which uses a AI system created by us, which is named as Grind Mind AI. The system is integrated with various sensors and AI adaptive processors. Like, first of all, it scans the surface, which are we gonna process on or finishing. So first, it's scanned with laser or optic sensors, which gives accuracy of 94%. Like, it's accurate, highly accuracy. Then it provides that data to AI adaptive software, which analyzes the surface and which gives data to the motor controller. And motor control operates the whole machine and helps the tools or the cutter which we use for grinding. It gives a specific length, depth, and adaptive quality to the surface.
Now, I will show you. Now, I will try to show you our dashboard demo. This is GrindMind dashboard demo prototype, which is visual right now. It is divided into 3 sections. First, left section, live sensor telemetry. These are the live reading from a grinding machine, which shows the current reading time of how the machine is performing. It has 6 parameters right now. Spindle RPM, which shows the speed of grinder moving on the workpiece. And second is force, which is acting on the workpiece from machine. Third is workpiece temperature. The temperature on workpiece increases or decreases, which reduces its quality. So the real-time temperature is shown on dashboard. Fourth, vibration. The during process, the robot shakes, which also reduces the efficiency and its quality. So so by seeing the vibration, we can stop the machine or improve the production. Then motor power, the electrical power the motor is using, and surface roughness. It shows the smoothness of surface during process. The lesser the value, the smoother the surface. Then we have another 4 parameters, process parameters, which controls the main grinding process. It has flow rate, depth of cut, coolant flow, and speed. The flow rate indicates the workpiece movement during process. Depth of cuts show us the removed material during process. Coolant flow tell us how much coolant liquid was required during the process to cool the workpiece. And for the speed of spindle. And then one of the most important feature of our GrindMind AI, adaptive override. During process, many times the parameters fluctuate, and it also one of the most important reason of tolerance. This adaptive override uses AI and automatically adjusts the parameters when they changes, and they crosses the limit of normal. This adaptive override always observe the readings of sensors and compare with normal readings. Whenever the readings fluctuate and move over normal range, they automatically controls them and change without any manual support. Then autonomy detection, sorry. This detection technology is also one of the most key feature. The roughness, the uneven surface creates finishing very bad. So by this feature, it detects the unevenness and rough surfaces and takes decision on its own for what to do for patches, what to do for depth. It should be forced more or leaved. These decisions are taken by its own, without any manual help. And auto dressing trigger. When spindle is moved, the wheel of it is also moved, and by certain time used, the sharpness of it is reduced, and sometimes manually it got skipped and used again, by which the tolerance and efficiency also reduced. So this auto dressing trigger helps and detects the sharpness of that flow of that wheel, and tells the operator to change or resharp the wheel. Then in middle, we have grinding force bar, which shows the force acting on the workpiece from machine during the process, and it is currently linear. When the lines is in green area, and it is in blue color, mean they are in control. When they overflow the orange line, means they are alert. There should be some change. Then workplace temperature, workpiece temperature. When the process is done, the workpiece also got heat. Sometimes it got much heat that it reduces its roughness, and which reduces its efficiency. So this workpiece temperature bar graph shows us the temperature during process, and when it exceeds the limit, it alerts the operator to stop the process. On right side, it is ML cycle prediction, means it predicts the next cycle possible in time, and when it matches the current actual cycle and AI prediction, it means it is actually predicting the correct predictions. Then it shows model name, errors, which can be changed according to our workpiece required. Then adaptive control actions. These are based on adaptive override. Just like adaptive override, we give permission to machine to take decisions. Here, its report is came. When the decision is made by its own, it creates a report and shows on adaptive control actions. What action it take when the parameters fluctuates. Then cycle. Then event anomaly report. It is also one of the report which shows how roughness and evenness was on surface, and it reduced the surface and increased the smoothness. Then It is the top, and the last factor, top feature important sense. These are the important factors of adaptive or auto racing trigger, which was used to create the tool, which was one of the important factor which affects the production. Here the force and temperature affects the most, while vibration doesn't affect the product. So this is the dashboard which will be used in our project, and which uses AI and ML and adaptive technology to increase the efficiency and intelligence of robotic grinding machines.
In, in current grinding methods, the surface det, det, in current grinding method, the surface detection is used in depend upon manually, and then manually inspection में accuracy कम आती है, तो accuracy कम आती हो तो standard robotics grinding method system is a grinding depth is pre-programmed, that's the robots is cutting a material by without analyzing some breaks.
Now I will explain the ROI proof. These are some measurable impact of AI-driven grinders. First, it improves the surface finishing accuracy up to 40%, and it reduces the production time up to 25%, and reduce in material waste up to 30%. Low energy by using this AI, low energy consumption are used. Improve production efficiency. AI-driven grinder provides faster production and high precision manufacturing.
So our ask is to transform GrindMind AI to a virtual prototype into a real industrial AI grinding solution. We required real access to manufacturing environment. As you said, you have a rich data of 40 years. So it would help our AI model to get trained well, as the industry needed. Real-time manufacturing environment, production data expert, and guidance of industrial mentors to validate a refined adaptive grinding system. Thank you, sir.
The finishing or the grinding challenge is not an easy one. I am very happy that this team has come out with a bunch of interesting ideas. Some of them are practical even today. Some of them might become practical in the future with an availability of sensors and availability of other devices which are needed for implementing those ideas. Going forward, we will be happy to mentor the team and to make our workshop and a research lab accessible for the development of this kind of a technology in the future. Thanks a lot for your inputs and all the best.
Thank you, sir. Thank you.
Thank you, sir. Thank you, students. So I would request Mr. Samir Kelkar, sir, and the students to please come forward on the dais for a group photo, and also Mr. Madhup, sir, to please join them on a photo, please.
Like one last point, like not only for these students, but like other students here, like some of them were hesitating a little bit to talk in English. I think AI कोई like language नहीं देखता, आपको हिंदी में बोलना है, मराठी में बोलना है, as long as you can explain the concept, like please feel free to talk in any like language that you will choose. Thank you.
Thank you, sir. Thank you, team. So as we conclude this Inspiring AI Summit today, we witnessed industry leaders presenting real challenges, students responding with innovative thinking, experts discussing the future of AI and robotics, collaboration between academia and industry. So thank you everyone for coming today. I formally conclude today's session. Tomorrow we will meet at 9:30 a.m. same in this Rukmini Auditorium for day 2. And the remaining track is Agriculture and Climate AI. So thank you everyone. Thank you very much.